In this section, we want to look at long-range behavior of functions. We want to know whether the graph eventually rises or falls. This can be determined by the function's degree, even or odd, and by its leading coefficient. Now again, one of our goals is to be able to see a function without having to use a calculator to draw it. So power functions will be used since long-range behavior is the only behavior involved in this video. The next video will deal with short range. We're going to be using the leading coefficient test. The leading coefficient is the coefficient of the highest power of x. When n is odd, that's the degree of the polynomial, if a sub n is greater than 0, it's going to fall to the left, rise to the right, and do the opposite if a sub n is less than 0. So let's look at some examples here. Let's plot 2x cubed. X equals minus 2 to 2. We'll put it on a certain range here. Okay, notice that a equals 2. A was greater than 0. Odd degree falls to the left, rises to the right. Let's look at minus 2x cubed. Now you already know that that's going to be a reflection over the x-axis, so there's the graph. Notice the important thing is that it's of odd degree and a is less than 0. So it falls to the right, rises to the left. Okay, what about if the degree of the polynomial is even? Notice it's going to either rise on both sides or fall on both sides, depending on whether a sub n is even or odd. Let's start by plotting 2 times x to the 4th. We'll give it a range here. Notice a sub n is 2. 2 is greater than 0. 4 is even. One of the things you want to remember is that any polynomial, its degree determines its long-range behavior. Nothing else, just the degree. So here we're going to reflect this over the x-axis. Now in this case we have a minus 2. We have an even degree polynomial, and so it falls to the left and falls to the right. Now the leading coefficient test only helps with the right hand and left hand behavior. Other characteristics such as intercepts and extreme points must be determined by other tests. So based on the leading coefficient test, the graph of the polynomial rises to the left, falls to the right, since a is negative 3 and n is 5. In other words, odd degree. Notice, rises to the left, falls to the right. Kind of interesting the way that's going to happen. And we didn't have to worry about all the terms in the middle, just the fact that it was x5.